Price sensitivity analysis through advanced sensitivity analysis. The alternative method for determining break-even price uses advanced sensitivity analysis, the third tool on the Advanced Analyses section. 142. Select this option. This command allows you to determine the effects of inputs on at-risk outputs, in our case, NPV. An input can be either an at-risk distribution or any cell. In this case, we will sensitize years 1 oil price. An input cell does not have to contain an at-risk function. This tool runs a full simulation at each of a set of possible values for price, tracking the simulation results at each value. The results then show how simulation results changed as the input value was changed. In each simulation, price is fixed at a different value across its range. Typically these stat values are different percentile values for the input distribution or, as we will do here, at different interval values for price. 143. By clicking on the Cell to Monitor reference icon on the right-hand side, make a reference to NPV. 144. Click OK to return to the sensitivity definition dialog. 145. Click on the Add button. 146. Change the type cell to cell, since our price no longer should contain a PERT distribution. 147. Reference should be made to cell B15. 148. On the variation method select values across range. 149. Change the minimum to 30, and the maximum to 70. 150. Change the number of steps to 5. In this way, the tool will analyze 5 equal interval prices at $30, $40, $50, $60 and $70. 151. Click OK to finish this dialog and return to the major dialog for advanced sensitivity analysis. 152. Proceed to analyze. At risk will warn you on the number of iterations and simulations that will be executed here. Just make sure you have 1,000 iterations instead of 5,000. If you were to sensitize here with 5,000 iterations it would be more precise but it would last 5 times longer. 153. Proceed with OK. At risk will now run 5 simulations with 1,000 iterations each. At each one of them, all stochastic input variables on the model, that is, all the variables that contain an input at risk function, will vary according to their respective distribution functions. So to speak, the only stochastic variable that now assumes 5 times, a fixed, non-moving value, will be oil price, which will be changed 5 times over. At the end of this process, At Risk will have created a new workbook with summarized reports for its sensitivity analysis. It contains 4 tabs with summarized sensitivity information. 154. Go to the first tab, Summary. On first analysis line, row 10, observe the results where oil price has been set up at $30. The mean NPV would be -$32.7 million. Results could vary from a minimum of -$99 million to $71 million. On the other hand, with a price of $70 per barrel at row 14, mean NPV would be of $118 million, with a minimum of -$23 million and a maximum of $330 million. As a matter of fact, you could compare graphic results of these 5 simulated scenarios. 155. Return to the original workbook Oil Production Forecast Solved and Step on NPV, cell B26. 156. Click on the Browse Results button. You will now see the NPV curve for At Risk's first simulation run with a fixed initial price of $30. 157. Click on the Select Simulation Number to Display button and select Show All Simulations option. The following chart appears. We still need to make several changes on this chart in order to make it more readable. 158. Place your cursor on top of the probabilistic bar. 159. Right-click on the bar and the following context-sensitive dialog appears. 160. Select the first delimiter options for At Risk to open the Graph Options dialog at its Delimiters tab. 161. Change number of delimited curves from 2 to 5 and close with OK. 162. Drag the left-hand side wall of the statistics table to the left in order to allow for its expansion and show all 5 columns. Sometimes inserting density curves on overlaid mode does not allow for a clear reading. Some people prefer, at this point, to change the chart for a cumulative ascending type of chart. 163. Click on the cumulative ascending option of the S-shaped type of chart icon at the bottom part of the chart to change it to a percentile type of chart. On S-shaped charts, Also called cumulative ascending or percentile charts, the y-axis shows the cumulative probability of each one of the productions at its matching x-axis intersection. 164. For example, write 0 on top of the vertical left-hand delimiter, and $50,000 on top of the vertical right-hand delimiter. The chart should now look like this. Left P statistic shows on the table the cumulative probability of having a result smaller than or equal to 0 in this case. At a starting oil price of $30, the probability of having a negative NPV is 89%. At an intermediate starting oil price of $50, the probability of having a negative NPV is 14%. If the starting point for first year's oil price were to be $70, the probability of a negative outcome decreases to almost zero.